This is Dr. Holt. I'm going to work a physics problem called inclined plane problem or problems. We're going to look at an inclined plane with a mass seated on the inclined plane where there's no friction. These problems are fairly easy. Just follow a methodical approach that I'm going to show you, and I really don't think you'd have much trouble. Even when we get into friction, and I'll do another video on friction, it's really pretty much the same approach. The only difference is you've got to be a little bit more concerned about the normal force. So look at the problem here. I'm going to take a mass, a 50 kilogram mass. It's going to be sitting on the inclined plane where the angle of the inclined plane is going to be 40 degrees coming off the horizontal. What I recommend to my students when they do these problems is go ahead and set yourself up a new axis system. I'm going to have anything that's parallel to the inclined plane as x prime, everything that is perpendicular to the inclined plane is y prime, and then we're going to work strictly in this axis system and ignore the x axis and the y axis. Alright, let's go back and let's get this problem started. The first thing you're going to do with a problem like this is go ahead and draw what's taking place here with the vector. So what we have here, and we're going to point what's coming down onto the inclined plane. I'll draw the inclined plane like this. Obviously my angle looks a little bit greater than what's shown above. Oops, let's move this up. This is going to be your 40 degree. This mass coming down, or this force coming straight down, is going to be equal to 50 times 90.8. Now if we take 50 times 90.8, we're going to get that as 490 newtons. And that's coming straight down onto the inclined plane. Okay, so now we said we're going to use a new axis system, so this will be a y prime and this will be our x prime. Okay, second thing you're going to do is break this into its x prime and y prime components. It's going to make your life a lot easier. We're going to come down here. This will be the f o y prime, meaning the force of the object in the y prime direction. We'll go ahead and create this vector right here. That's going to be the force of the object in the x prime direction. Now, really the key to this, if this is 40 degrees, this angle right here is going to be 40 degrees. And that's always going to be the case on an inclined plane. Whatever this angle is, if this is theta, this is theta. Do not make this your 40 degree, because then you're really going to royally mess up these problems. So here's going to be your right angle, and that's your little triangle. So now let's go ahead and run what these values are going to be. So F, the force of the object in the y prime direction, is obviously just going to be 490 times the cosine of 40 degrees. And the reason the cosine, because it's the adjacent to the angle. When we run that value, that gives me 375.4 newtons, and that's coming straight down in this direction here. We'll go ahead and find out what the force of the object in the x prime direction is going to be. That's going to be 490 times the sine of 40 degrees, which is going to give me 315 newtons going down in this direction. Alright, so now if we draw what's called free body diagram, I'll move this over here. What's really taking place is you're going to replace the 490 newtons with its components. Okay, so what we'd have would be the 375.4 newton coming down here on the inclined plane. And I'll just kind of draw a real rough. Let's represent the inclined plane. You're going to have the 315 newton coming down like this. And then you're going to have a normal force, which you have to have a normal force, or the object's going to go right on through. It's going to accelerate right on through the inclined plane, and this would be our normal force. If we summed up the forces in the x prime direction, then I'm just going to make that minus 315 newtons because it's going down and going toward the left. And then if we do the summation of the forces in the y prime direction, then I'm going to have minus 375.4 plus our normal force is equal to 0. So then we know our normal force is going to be 375.4 newtons pushing back up. Okay. When you have no friction, really the normal force isn't necessarily relevant to the problem. When you get into friction, then we need to consider the normal force, because we know that the frictional force is going to equal to the normal force times mu, or the coefficient of friction. Alright, now, if the only net force we're going to have right here in this problem is this, because everything is in equilibrium in the y prime condition, but it's not in equilibrium in the x prime condition. So this would be our force. We go back to F equals ma. So F is equal to the mass of the object times the acceleration. We go ahead and put the values in. So I get minus 315 newtons is equal to the mass, and the mass of this is 50 kilograms. And that's times a, the acceleration. If we run that number, 315 divided by 50 will give us an acceleration of 6.3 meters per second squared, and you can make that negative, or you can show it as a vector quantity going down to the left. So either one's fine. We know the object's going to accelerate down the inclined plane at a rate of 6.3 meters per second squared. Alright, excuse me. Hope this video helps you understand how to do inclined planes where you have no friction. Again, just follow a methodical approach. The whole problem will fall apart and you'll have an easy solution. Best of luck.